So, welcome to all of you. In this video, we are discussing the part number 4 of INV streams. So, in this part number 4, we are discussing piped input stream and piped output stream, then followed by sequence input stream, then followed by file filtering example and file object example. So this I am going to cover in today's session. So coming to the piped streams. In IO streams, so far we discussed file input stream, file output stream, buffered input stream, buffered input stream, binary input stream, the next binary output stream, string buffer input stream, data input stream, data output stream, buffered input stream, buffered output stream, print stream, line number input stream. So far we covered these many classes. And now currently we are discussing piped input stream, piped output stream, sequence input stream. So these are the IO classes we often use in Java programming. Socket input stream, socket output stream comes in the networking topic. And one more very important input output stream class is object input stream and object output stream. This we will discuss in the next topic, in the object serialization topic. After that, random access file. Finally, we will end up with the writers. So coming to the piped input stream and the piped output stream. What is the use of these two? And how this piped input stream output stream concept is different from the other previous file input stream and file output stream concepts. For example, in file input stream, if you open one file input stream, one file output stream on two files, student details 1.txt. With file output stream, we want to write to student details 2.txt. So from the file, we'll read one byte, we'll check while, we'll take an integer while I is not equal to -1. That means if stream does not reach to -1, end of the stream, then using file output stream, we'll write that byte into student details 2.txt. Again, we'll read next byte, file input stream.read. And then sequentially, byte by byte, we'll read each byte. We'll check whether the byte reached to the end of the stream or not. Then we are writing into file output stream into another file. Read next byte and so on. The loop will iterate until the student details 1.txt file content is completed. But coming to the piped input stream and piped output stream concept, sometimes the requirement comes in such a way that one of the input stream, one of the output stream may write from one thread, and from another thread, one input stream want to read the data. Say for example, from the network, we are getting some data, especially if you take server socket programming. There is a client system and there is a server system. Client opens one socket and on server one socket will be opened. Client wants to read one file and he wants to upload that file content to server. The client side socket reads the data from the file and it sends the data to server socket. This is client side socket, this is server side socket. It sends the data to the server. On the server system, here through via socket the data is coming here. Here we want to run one thread that will use one input stream, and with the help of an output stream, it wants to write the data into another input stream here. And whatever data comes through the socket, here the socket, here one thread running in the socket, with help of output stream, it wants to write the data into, it won't write the data into one input stream here. Input stream should read the data and it should write the data into one file here on server system. And if output stream runs in one thread and input stream runs in another thread, if you want to sync the data reading and writing between these two thread operations, there we have to use piped input stream and piped output stream concept. And if one thread writes the data, if another thread reads the data, in that case, we'll use this pipe streams. If you read the heading about piping mechanism, piping is a mechanism where we provide the output of one stream as input to another stream, as an input to another stream, as an input to another input stream. On this, I have written some documentation here. A piped input stream should be connected to a piped output stream. Piped input stream should be connected to piped output stream. And whatever data written by piped output stream, that piped input stream will read the data. The piped input stream that provides whatever data written to the piped output stream will be read into piped input stream. If you see one example, you will understand. So here, through a piped output stream and data output stream, the data is written through a one pipe. The data comes through piped input stream, and through a data input stream, we'll read the data. We may write it into another file, or we may print it on the console, or we'll perform some operations. That's a different case. If you see the example here, this is a best example. Here, this is a piped input stream example, piped input stream, piped output stream demo example. Here, I created one piped output stream object. Here, I created one piped output stream object. That piped output stream object we have given as argument into piped input stream. We just created one blank piped output stream object. Nothing is there. It's a simple piped output stream object. That piped output stream object we are giving as input to piped input stream. That's it. Okay. Finished. Now, and what we are doing here is this piped output stream we assign to one thread here, and the thread process is started. Now we'll go and see what thread will do. Here we created one piped output stream object. Piped output stream object is given to piped input stream, but here we are not performing any operations on piped input stream here. So what we are doing is we are giving this piped output stream object as argument to a data thread, and it is one of our own user defined thread. We are giving piped output stream object to one thread, and thread process we started. And from here, piped output stream will start writing the data via through one thread. So the moment thread starts into thread class constructor, what is coming here? Output stream object is coming here. And here in the thread class, we must receive one output stream class object here. That output stream class object is assigned to class instance variable. So, which method we use in threads to implement thread logic? Run method, isn't it? In the run method, what we are doing is, here I took one string is equal to A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, something like that. So, in the run method, what we are doing, we are sending this piped output stream object as argument into data output stream, because piped output stream, like the normal output stream, it is having only one method called write method, through which we can write byte by byte, one byte. So if you pass that piped output stream object as argument into data output stream, data output stream advantage is data output stream is having methods or write methods of various data types, write in, write long, write float, write double, write char, write boolean, write bytes, write chars. Write bytes writes each and every character whose size is 1 byte. Write chars writes one character which occupies 2 bytes of memory. So in the data output stream, the write bytes method is available that will take string as argument. So in the data output stream class constructor, we are passing this output stream object, and through a data output stream object, we are writing that string A, B, C, D, F, G, H. That through data output stream object, the string is returned. The data comes to output stream. Which output stream object it is? This output stream object belongs to piped output stream. So into piped output stream, through a data output stream, one string data is coming to this piped output stream. This piped output stream we have given to which one? Which object? We have given to piped input stream object here. Now here you see the piped input stream object we are giving to data input stream, and in the data input stream class we are having one method called readLine. So through a piped input stream object. Piped output stream object is given to piped input stream. Piped input stream is given to read line method, because piped input stream is having only one read method which reads byte by byte at a time one character. But whereas if you give that piped input stream object to the data input stream, it can read one line of data at a time. So whatever data is being written from here, data output stream dot read bytes, that data we are reading through a data input stream dot read line. You may get very big doubt. The same process we did in the previous examples using file input stream, file output stream also, and data input stream and data output stream also. But there the point is each byte we previously we read, and the next in the immediate statement using file output stream we wrote the data into file. The next again we read one more byte. Again we checked whether the byte is end of the character or not. The next thing we have written to the file, that byte to the file, and so on up to. And that process is completely a synchronized process. We are reading byte by byte and writing byte by byte. So both we are doing in a single method, single thread operation. Here the point of piped streams is, if output is written by one thread and if input is written by another thread, this kind of output stream writing output stream is written by one thread and input stream reading by another thread. This kind of concept will comes into picture mostly in the networking, web and distributed applications. Network applications, for example, if you write your own socket programming, web applications like, for example, when you develop applications with servlets, JSP, Struts, JSF, Spring, various things, and then next, like in the distributed applications like RMI, 4x, EJV, web services, SOAP-based web services, RESTful web services. So in all the server-side applications, client server always will get the data from the client. So server reads the data coming from the client through an input stream, through a one thread output stream, it will write the data. Through another input stream run by another thread, through which we read the data and we will write it into file. Or vice versa. Server will send one file data line by line or buffer by buffer or something. Server will send the client request for one file. Server will send byte by byte or buffer by buffer at a time or line by line at a time from server to client. Client needs one thread which reads the data. So output stream, it should send it to another thread. That thread, and this output stream is running separately. And writing the data is a separate thread which is independent of writing into, and writing thread is a different thread. So why we are separating it? Because sometimes the data which is coming from the server to client system, and why we are completely disengaging or demarcating or separating the output stream and input stream operations into two separate thread processes, because sometimes the data we want to write may be sometimes into a file, sometimes it may be into another socket object, sometimes it may be into a network, sometimes into a mail, sometimes into an SMS, and sometimes into some other process for the processing. So the whatever data coming from the output stream, the input stream sometimes it want to dynamically change its destinations onto various other destinations. So we want to completely demarcate or isolate or separate reading operations from writing operations. So then what we'll do is we'll run these two in two separate thread processes. So that is what we are doing here. And whatever data coming from the server, that completely independent of where it is being written. It will be written to anywhere, different threads will write. One thread writing into file, one thread writing into another socket, one thread writing into database, one thread writing into log file, one thread writing into some network, one thread writing into some Excel, one thread writing into XML, one thread writing into CSV, one thread writing into JSON. So we write different thread processes for writing into different destinations. So this process want to completely get different from whatever the data we are coming from the server, the client reads, and where it want to be written is completely should be different. That should be separated from the one thread we are receiving the data from the server. So if you want to run two separate threads like that, so to link up between these two threads, these piped input stream and piped output stream objects will be useful. So we are here through that piped input stream, and whatever data comes into the piped output stream, that data will come into the piped input stream. That piped input stream we are passing into data input stream. Data input stream we are linking because of it is having read line method. So that we are reading line and we are printing it into and writing it into one file. So once it is written to one string, once it is taken into one string, so what the string will come? This complete string will come. Capital A, small letter B, capital C, small letter D, asterisk, capital E, small letter F, capital G, like that. Such a string is coming here that comes into S1. If you print that S1, directly the data will be printed. To increase the additional, to increase some extra logic, what we have written is, we are finding the length of the string, S1.length, I++, I is equal to 0, S1.length to I++. From string, we are retrieving each and every character using index. String class is having one method called character. In the character function, if you pass 0, 1, 2, 3, 4, 5, 6, 7 like that, character at each index will be written. CH. Character is a wrapper class. Like what are the wrapper classes available? Byte, short, integer, long, float, double, character, boolean. Or for 8 primitive data types, 8 wrapper classes are available in Java. But all these numeric wrapper classes are derived from number. And this character and boolean, these are derived from object. Number class is also derived from object, and character directly derives from object. Boolean class also directly derives from object. String class also directly derives from object. String buffer, string builder, all are derived from object only. Anyway, that is not the discussion here. Character is one of the, char is a primitive data. Character is a class. Char is a primitive data. Character is a wrapper class. And for this char primitive data, character is a wrapper class. It's having so many number of functions. You can visit java.lang.character class. If you type, you will get the API documentation. In the character class, some what you call static methods given. The point is like the why static methods? Most of the methods given in the character class are static methods. Most of the methods given in the character class are static methods. You know why? Because we don't want to store anything into character class and then perform operations on that character class object. Because character class after all contains only one single character. You need not have to store it into one character class object through constructor and then perform operations. After all, it is a single character. What exactly you want to do is you want to convert uppercase to lowercase, lowercase to uppercase, and you want to check whether is it a character or not, or is it a digit or not. This kind of what is the Unicode value of that character, or what is the ASCII value of that character, something like that. So for that, static methods are sufficient. The character class is uppercase method is given. Uppercase to lowercase methods are given in string class. Two uppercase and two lowercase methods are given in string class. That changes the complete case of the whole string into uppercase and lowercase. Two lowercase, two uppercase to convert into one. So here the method names are is beginning methods always written boolean value. It is like questioning. Is it an uppercase character? Like that we are questioning. Is uppercase of, you pass that character here. Whatever character coming from the string from each index. So if that character is an uppercase character, it will return true. So we want to convert uppercase to lowercase and lowercase to uppercase. And we want to inverse the case of the string. Character dot to lowercase. Here also two lowercase method is given. If you pass that character, uppercase character will be converted into lowercase character. Else we are checking. Else if it is not, character dot is lowercase. If the character is a lowercase, convert it into uppercase. If it is neither uppercase nor lowercase, and if it is a special character, like there are some special characters exist here. Asterisk, space, comma, space. These are all special characters, which are not lowercase or uppercase alphabet. So if the characters are any of the remaining characters, just print the character as this. Asterisk, space, any slash or anything if it exists, they will be directly printed. Here the idea is the output stream and the input stream want to be completely separated from each other. Writing into that process, and because we are having various types of sources here nowadays, say we can write data into files, we can write data into comma separated files, we can write data into XML, we can write data into JSON, into local hard disk files. Okay, then next we can write, these are all files only. We can sometimes want to write data into socket, sometimes we want to write the data into database. Sometimes we want to write the data into Excel file. Sometimes we want to write the data into XML file. Like that. Sometimes into through web application. Sometimes into distributed application. Distributed application architecture will explain in the next topic. In the object serialization topic. So different threads. If it is a single program like the previous data input stream, data output stream, or print stream, file input stream, file output stream. So the program, whatever you write, from where you are reading and where you are writing, completely that code is written in single main method. So that program always reads from the same source and writes on to the same destination. Here, the source and destination processes are completely executing by two separate threads. But how the input stream object and output stream running in two separate threads can link up each other with the help of these piped streams. That's why they named as piped. So there, the piped stream concept is completed. The next coming concept is sequence streams. This is very, very important. See, this is very, very important. This is very, very important because sequence stream. Sequence input stream and sequence output stream. So, no, sequence output stream is not this, only sequence input stream. There is no sequence output stream. Okay, there is only one sequence input stream. I'll tell you why. See, using file input stream object, we can read data only from one file, that too byte by byte. Suppose if you want to read from the same file, if you want to read data line by line, you create file input stream object, points to some file, give it to data input stream. Through data input stream, you can read line by line. If it is textual file, you can read line by line. Any textual format, HTML, CSS, JavaScript, Java programs, the next plain text file, JSON, XML, CSV, all these files. These are all text files. And sometimes if you want to read any binary file, like say images, audio, video, PDF, Excel, Word, etc., etc. If you want any of these binary files, which are not character files, textual files, if you want to read them, instead of reading byte by byte, we can read buffer by buffer. The textual files are read using data input stream and data output stream, and binary files are read using buffer input stream and buffer output stream. But file input stream points to only one file. If you give it to data input stream, you can read line by line. If you give it to buffer input stream, you can read buffer by buffer. Is there any stream available in IO streams? Is there any stream available in IO streams that can take multiple sources? Is there any stream available? It is one type of variety of, see, it is one variety of input stream class. Is there any input stream available in input stream classes that can read the data from multiple sources? Some data from file, as earlier I said, some data from file, some data from socket, some data from database, some data from XML, some data from JSON, some data from some CSV file. Like that, if you want to read data from multiple sources, for each source to read from one source, we will create one input stream object, one file input stream object, one socket input stream object, one file input stream object to read from XML, one input stream object to read from the JSON, one input stream object to read, file input stream object to read from the CSV file, like that. We are having multiple input streams. If you want to read data from these multiple input streams, each file input stream dot read operation you read, take it into one integer, the character as equivalent into one integer, while I is not equal to -1, print it or use it or store it somewhere, and again read the next byte. Iterate that loop. Once that first input stream is completed, again you start reading using file input, second file input stream, again while loop. Once it is completed, again you open third file input stream object or third input stream object, again while loop, iterate. And then different input stream objects, different read operations, different while loop operations, and the program length will increase. Is there any option available that so that I can give multiple input stream objects at a time, or multiple input stream objects or multiple sources into one input stream object at a time, so that it can read data from all the input streams or from all the sources at a time? So such an object is sequence input stream. Here, sequence input stream can read the data from multiple input streams, but there is no sequence output stream because no output stream can write data into different destinations. How come one sequence output stream knows that I want to write the data, some part into file, some part into socket, some part into etc. like that. So there is only sequence input stream available to read the data from multiple input streams, but there is no sequence output stream available to so that you can write into different destinations. How to know how much to write into which output stream? So that is a concept. So concept is clear. Is a concept is clear. I don't want to read this whole description here. Once the constructors or methods are shown, after that I can come to this document if you want. So if you want to read using sequence input stream, if you want to read from multiple sources, what to do is a sequence input stream must consist of, suppose if you want to read from two input streams. So for that, one sequence input stream class constructor is given that will take two input stream objects as parameters. And if you want to read one single input stream that reads data from two input streams, these two are given to here. So from here we can read the data. If there are two input streams, suppose if you are having multiple input streams, if you are having 5-6 input streams or 10-20 input streams at a time, then how do you read the data? But we don't know sometimes how many input streams are there, but we want to read data from all the sources. So for example, the news agencies, they will get the news in every 1 minute, or there is an interval for every 1 minute or for every 2 minutes or for every 5 minutes once. The news agencies will get the data from reporters from various districts, from various cities, villages, and from various places, from various states, from various countries. News reporters will collect the data and they will send it to news agency. But news agency want to read all the data coming from multiple locations. And here there will be a team like editors and so many number of people who collect the data. Based on the district, they will separate the data. Based on the type of news, they will separate the data. And they'll publish it into different parts of the newspaper. Or it may be sent to the TV media or print media. So we don't know from how many districts are from the states or from the cities or from the village. And there is no fixed count, like only data coming from two input streams, sometimes from 5, 10, 50, 100. So then how do you give multiple input stream objects as arguments? See, one input stream you can give, two input streams you can give, three input streams you can give. How can you give multiple input streams as argument in this sequence input stream class constructor? Can you guess? Can you pass one input stream array as a parameter here? See, in the sequence input stream class, one input stream array type, if it takes input stream array type, if it takes as a parameter, input stream array type, if it takes as a parameter, you can create multiple input stream objects, file input stream, different input stream objects. All you store it into one input stream array and pass that array's argument into sequence input stream class constructor. Done, finish. And if not individual input streams, you can pass array, or you can pass vararg. Vararg can be used. How to use vararg? Input stream triple dot. Yes. Vararg can be used as a parameter. Array can be used as a parameter. And one more option is, if you know collection API, two classes are there, vector class and array list class. Vector class is having one method called add. Generally, vector is a a collection. It is a dynamic array. It's a collection object which will take heterogeneous types of values, like different data type values. So vector class is having one method called add. So you give input sim 1, 2, 3, 4. You give a number of input sim objects into one vector object, and vector class is having one method called elements. That elements method will return an enumeration. Enumeration is an interface which will act like a pointer to each element in the vector. And it's like a pointer to array of elements in the vector. Pointer to the array of elements in the vector. So enumeration is having two methods called has more elements and the next element. Has more elements and next element. These two methods can be used in while loop to find out whether the next element is available or not. So in order to read data up to the end of the vector. So we are using this as a chance. Here another sequence input sim class constructor is taking enumeration interface type of object as argument. Actually here two more constructors could be given. One constructor which will take input sim array as a parameter, one will take input sim var as a parameter. Actually, like that, 4 constructors must have been given for our convenience. And in the sequence input sim class, one read method is given that will read byte by byte. Another read method is given that will take one byte array. Say for example, you create one byte array, b is equal to new byte array of. You give any 1024 multiples, 1024 at a time 1 KB. Suppose if you want 10 KB, you do one thing. At a time if you want to read 10 KB, 20 KB, 50 KB, like that, or 1 MB like that, into 1 EP. And it is 1 KB. Suppose if you want to read 5 KB, into you change only this multiplier. If you want to read 10 KB at a time, you change the multiplier 10 here. And this byte array size will automatically be determined based on 1 KB 1024 bytes into this multiplier. You create that much byte array, and you should know how much data is available in from all the streams, so that you can read 10 KB at a time, like that, for as many times as you want. Otherwise, you can read byte by byte. So two read methods are given. So here that is an example on this whole stuff. Here there are two files written, 1.txt and 2.txt. 1.txt contains I am 1.txt file content, 2.txt file contains I am 2.txt file content. These are all common. Import java.java.star, input sim example, sequence input sim example I should have write, public static requirement, two file input sim objects created, one points to 1.txt, one points to 2.txt, two file input sim objects. Both file input sim and file output sim objects are given as arguments to sequence input sim class constructor. One sequence input sim object is created. Here we are reading byte by byte, checking the byte is -1 or not, print that character, that line to the console. If you want to write it into one file, you can write it. Then next read another byte, then check again whether the value is -1 or not, then again print, then again read, and so on up to, you read up to the end of, and a single sequence, instead of operating on 2, 3, 4, 5, 6 file input sim objects with individual read operations and while loop operations. You club all of them into one sequence input sim, and as a single input sim object, you read up from all the multiple input sims at a time. So finish. Finally, we are closing sequence input sim object and two file input sim objects. The next program is reading from two files and writing into another file. See, here what we are doing is, we additionally created one more object called one file output sim object pointing to output.txt. And from the input sim, from these two files are read. Now final output is like this. Final output will be written on the console like this. Here two file input sim objects, one file output sim object pointing to output.txt file. And both input sim objects are given as argument to sequence input sim class constructor. Sequence input sim object is created. First byte is read. If that byte is not -1, if it is not equal to -1, if it is not end of the string, write it into this file, output.txt. And again, here only every byte will be read and checked and assigned to I. If it is not equal to -1, loop will continue. If it is equal to -1, loop will be terminated. So you need not have to write this sys.read operation next to the fos.write. This itself will read, assign to a variable, and checks the condition, everything in that line. So that's how we are writing into one file. Finally, sequence input sim closed, while output sim closed, two file input sim objects closed. So if you open output.txt file and see the content, you will see the content like this. If you want to read from multiple input sim objects, as I told you before, file array could be one option, but such a suitable constructor is not given. One input sim var type constructor should also be given, so that is also not given in the sequence input sim. But in the sequence input sim class, one enumeration type object is argument constructor is given. So you create 4 input sim objects, 1, 2, 3, 4. Create one vector object, store all the 5 sim objects into vector, and you call vector.elements. That's written enumeration. You pass that enumeration object as argument into sequence input sim class constructor. From the sequence input sim, you read each byte. If it is not -1, print it. Read another byte, like that till end of the string. The difference between previous program here, this program is there. We read data only from 2 input sims. Here we are reading from multiple input sims. There also we wrote it into one file. Here also we are printing onto console. If you are interested, you can write it onto one output.txt file. Who objects nothing. Again, this sequence input sim can be assigned to data input sim so that you can read line by line. You can assign it to buffer input sim so that you can read data buffer by buffer. That is all your choice. So that ends sequence input sim. The next coming to file extension filter demo. File extension filter demo, for example, if you open a notepad, here you will find one menu called file. In the file, you will find menu items called new, open, save, save as, like that below and exit. These are the menu items. They are the menu items under file menu. Suppose if you click on open, one file dialog box will be opened. Here all the files are shown. Here below, one text field will come. Here you enter the type of text field. Here all file types, text, Java, CSS, JS, HTML. Here all the types, and here we will get an option to enter the file name. Here we can choose the file extension, or otherwise you can put the file extension here and click on search or open. Then it will show you all the list of that extension file. If you select like I want a .java file starting with A, only files which are beginning with A with the .java extension files will be shown here. Right? In the open dialog box, in the open file dialog box, before open a file, we can filter the files with the help of file extension. From those list of files, we can choose another file to open. So we are having that option. Similarly, we can save also. See how such type of file filtering option should be performed. In order to perform that, one interface is given in the Java.io package called a file name filter. This file name filter interface is having one method called accept that takes 2 arguments. One is directory, in which directory we want to search, and for which file name we want to search. In which directory we want to search and for which file name we want to search. So if you give that one directory name and file name, wherever that file comes in this directory, wherever that file is found in this directory, to all such extension files, the boolean value true will be returned. To whichever file names the boolean value true will be returned, those files will be returned to the client. See this example. Better before starting this, before starting with the filter class, you see this client program. File filter demo 9. Here we created one object called file f is equal to new file of C drive material score Java AM3 Java IO input output sim some directory. Input output sim examples in my system are resided in this directory. It is now the file object is pointing by a directory, not file name. In Java, a class named called file is given. This file class object can point to a directory, or it can point a file. It can point a file or it can point a directory. Anyone, anytime. So here file object is pointing to a directory. So that is done. It's pointing. Then here we are creating one Java file name filter class object. What is a Java file name filter class object? It is not a predefined class. Remember, it is not a predefined class. Then what it is? So if you want to filter the files in a directory, then what you need to do is we need to write one class called Java file name filter. Implement some which interface? File name filter. So in this class constructor, in the Java file name filter class constructor, we are taking two arguments. What are the two arguments? Which type of which character beginning file you want to open, and which extension file, and which character beginning file and which extension ending the file you want to open. Those two unit passes arguments into Java file name filter class object. And the Java file name filter class constructor takes two arguments, which character beginning file and which extension ending file you want to filter. Those two arguments you need to pass as arguments here. So those two, start and file extension, both are coming here. And we are looking for files beginning with F and ending with Java extension. Start and extension. So these two are assigned to two class instance variable called file starts with the file extension. Once that constructor is completed, in this class, which method we need to implement? Boolean method. That Boolean method will take a directory object and string file name as argument. See, who will call accept method? Who will pass file object? Who will and a file class object, and who will pass the file name as argument here? In sense, once a file name Java file name filter class object is given, where it should be given, file class is having one method called the list. Generally, here the list method is overloaded for 2 times. Suppose if you call file.list method without any argument, you will get a string array. Do you know what that string array contains? The string array contains all the files and directories exist in this file object. File.list method will return an array that contains all the list of directories and files exist in this. Because file object is pointing to some directory. In this directory, if any directories and files are available, they all will be written in the array. Here into the string array, the written strings are the files and directory names exist in this file object pointing directory. So that is list method with no argument. If you call list method with no argument, you will get all the files and directories exist in the directory. There is another list method exists in the file class that takes file name filter class object as argument. So we are passing Java file name filter class object as argument here. Once file object is pointing to this directory, in the file object list method we are passing Java file name filter class object as argument. What this Java file name filter class object is having? File beginning with which character and ending with which extension. These two arguments. So this list method internally. What this list method does? This list method will internally call on the Java file name filter class object. What it will call? The list method. That list method will internally call. This accept. So in this accept method, it will pass the directory name, file directory name. The directory name is this name and comma string name as argument here. Java file name filter class object F and Java. So here in the name we are checking the conditions. What are the conditions we are checking? If boolean value is equal to false. If the file name and from this directory each file will be passed as argument here. Each file is passed as argument here. That name we are checking. Name dot starts with, ends with are the two functions in the string class. Starts with, ends with, index of, last index of, to char array, get char su, get bytes su, to lowercase su, to uppercase su. These are the methods exist in the string class. So each file name will be passed as argument. Here we are checking if name starts with so what we passed as argument here F. And once if file name is passed as argument, here we are checking is file beginning with F or not. And one more condition is file ending with the extension or not. Is file beginning with this character or not. Is a file ending with this extension or not. That we are checking. So each file from this file directory, and who calls this accept method? File object dot list method. File name filter class object is passed as argument here, right? Java file name filter class object is passed as argument here, right? So during this method call, this list method will pass this file directory and the file name as arguments here. Each file name is argument here. And then to call the accept method to this file object dot list method, we are passing file name filter class object. File name filter class object is already having two arguments with which starting character the file should start with and with which extension the file should end with. So this list method will call the accept method. This file object, the directory, and each file in the directory is passed as argument here. Here we are checking if the name starts with this whatever we passed the F here and then ends with Java extension or not. We are checking and returning true. For whichever files this accept method returns true, list method will return those array of files as a return. That is a string array. And f.list method return is string array. The string array is a list of files. Whichever files begin with and ends with this. And to whichever files the accept method returns boolean value, the silence will come to client. So client will print all the values. So here after completion of the list method, what we are doing is here we are getting string array that we got into one file array. How to iterate loop? To iterate loop, two options. One is find out the length of the loop. From 0th index, you iterate loop up to the less than length I++. Each index value you access. Otherwise, you can directly write for loop string file colon files. And from this array, each file name will be stored into one file object. So you can use any one of the way and you print all the files here. This is example on file filtering demo. And the next example is this example covers you create one file object. Using that file object, we want to find out whether the file object is pointing to a file or not, or a directory or not. That we are checking here. So determine file or directory. The example number would be 10. I forgot to name the number of the class, number of the example. Determine file or directory, or find out whether the file object pointing one is file or directory. Class name, main method. File object is pointing to some directory name here. File object is pointing to some directory name here. Some C drive, D drive, materials, core, M&M, some directory. And the next one is file object dot is directory. Is it pointing to a directory or file? It's pointing to directory. If it is pointing to a file, it should be something like 1.txt. Because this one IO streams is a directory, this is directory method will return true, is file method will return false. This program will just print true and false in most of the function requests. The output is true or false. The next file object is also pointing to a directory, IO directory file. Actually, before calling this method, here file object is pointing to a directory where this director file is a non-existing directory in IO directory. In G, materials, core, M1, IO, there is no directory exists with the name called file. If non-existing directory name, if you give us argument here and call f1.make directory, automatically the directory will be created. Though this I1 file, these two directories are not there, only if you are having up to material core M1 IO, inside IO file directory if not there. A single F1 dot make directory will automatically create one IO directory. Inside IO directory, it will create file directory also. And through Java program, we are creating directories. And actually, and here the file object is pointing to C drive Windows Notepad.exe. Notepad.exe is an executable file. So file object is pointing to Notepad.exe file. It is pointing to a file, not a directory. These two, F1 and F are pointing to directories. F2 is pointing to file. Here we are checking. And here also you need to check if this F2 dot is directory is file. Then is directory will return false. Is file will return true. Plus extra methods are the file object is having can execute, can read file, can write file. And each file class is having file attributes, isn't it? If you right click on the file and one drop down menu will be opened. If you go to properties menu item, file properties will be displayed. Read, write, some archive, some checkboxes will be even hidden like that. So if you click on read, write or hidden or archive, based on that, file attributes will automatically change. So the same thing we are doing here. Can execute, and is it executable file or not? .exe, .bat, .cmd. These are all the executable files in Windows. .sh is executable file in Linux and Linux and Unix. On Solaris.sy is the executable file extension. So these are the executable files. So that is what we are asking. Is file object pointing file? Is it can be an executable file? It will return true because it's pointing to file which is an executable file. Can read and can write depends on that file attribute, whether is that file is readable or not, writable or not. The next here we are pointing to temp.txt. So S3 dot create new file. Here create make directory. This directory is a non-existing directory. Make directory will create this file directory. Here you are pointing to file object that is pointing to a temp.txt file which is a non-existing file. F3 dot create new file will automatically create one temporary file, one temp.txt file which is an empty, blank, 0. So here we are just printing F3 dot last modified. Last modified enter when file is newly created, its last modified date is nothing but its created date. If it is modified further, then its created date and last modified date will be different. Last modified date is the date when you store data or when you appended or override some data, when you make some changes into the file. That date will be the last modified date. Last modified. That is, this last modified will return a long value which is a number of milliseconds since 1970 January 1st. January 1st. Since 1970 January 1st to till date, the number of milliseconds are written by long last modified. So long value will come with, but we don't know the exact date. So if you pass that long value as argument into java.date, then the actual date will be printed. Or that when that file is created, or when that file is modified, that date will be printed. F3.length, because there are no content in the file, 0 will be printed. Is hidden because we have not applied any hidden attributes. So this will return false. And this statement is kept in comment. F3.delete. If you write F3.delete, the moment the statement executes, immediately the file will be deleted. And then through a file object, how to create a new file and how to delete the file is file object that create new file will create the file. F3.delete will delete the file. Delete will immediately delete the file, but if you want to delete file soon after completion of this program execution, after completion of our program execution, if you want to delete any file, then instead of calling delete method, you can call delete on exit. Delete on exit will mark the file to delete. Once our program exits, then the marked file will be deleted. So delete files during JVM termination. So we use this file.delete method or delete on exit methods in random access file example. And the next topic is serialization. That next topic is what you call random access file. There we use this delete method. The next F3.get absolute file, get absolute path, get canonical file, get canonical path. All this will return the same thing. Get absolute file will return path up to the file. Get absolute path will return up to the file's directory. And then up to file, get absolute path will return. Get absolute file will return up to file name. Same thing canonical path and canonical file also. Get name will return only the file name. Get parent will return only up to directory. Get path will return the complete path. Path and till up to directory and file. Get parent and up to directory. Get name and only up to the file name. So that is how with the help of file object you can perform different operations. So here file object F4 is pointing to C drive. We are getting the total space and usable space. And then we are finding the hard disk space here. And here this file object is pointing up to IO streams directory. F5.list. And the previous list operation is the filtering operation. Java file name filter object is passed this argument here. Only files beginning with F beginning and ends with .java extension files are only written. Here all the list of files are written. Each file may be a file or it may be a directory. So, but file array will be written. Find out the length, 0 to length, less than length. Each file name will get right files of, will write files of that I value will write. And the files of 0, 1, 2, 3, 4, each file name will come. Again, you pass each file name as argument into one more file class constructor, into one more file class object. F5 is pointing to this directory plus double backslash. Each file name you append there. Because IO streams subdirectory names, its file names will be appended here. Such a file object is created. And here we are checking if that F6 object is pointing to a directory or not. If it is pointing to directory, we will print that so-and-so is a directory. Else so-and-so is a file. That is it hidden or not to find out F1 is hidden. So it will print whether the file is hidden or not. And the last example is getting all the list of files from a pointing directory and again finding whether that each file is a directory or not. If you run this program, you will get a very big output. So this is about file operation, file object example. This is file filtering example. And the next, this is sequence input stream example. And this is piped input stream example. Here ends the topic called piped input stream, piped output stream, sequence input stream, file name filter and file object demonstration. Thank you. Bye.
Like, share and subscribe. Hit the bell icon for more updates.